Hello, hello, welcome. Hi guys, it's been a while since I've live streamed actually, and I'm sorry I'm starting so late, but I needed to have a nap after work. I've been coming off from the anesthetic, I've been to dentist, and I was not in shape to host a live stream or think logically, so now it's a little bit better. It's hitting 10 p.m. in here, and obviously I've got, where is it? Here. I've got these little fellas that everyone's talking about today, if you're into Raspberry Pi. So that's obviously Raspberry Pi Pico. They hit yesterday in the morning. I got the news quite late, so I wasn't able to post it as quick as I wanted and get all those precious clicks. But I have them quite early, so I get to scratch my head on the live stream and try to figure out how to make them connected. I have a LED strip that we can use, and maybe we'll try to do something live, and maybe you'll help me out to figure out. I've not played with them. I literally just taken one out of the packet just to take a picture for the thumbnail of this live stream. So welcome guys, hands up if you already got one, or if you have one coming to you. I'm curious how many of you are gonna try it out. Right now they are showing us unfortunately sold out on P-Hut, so I was quite lucky, and it's I think one of the reasons I took a 3 because I knew they're not going to be available for some time. I'm gonna be monitoring the chat, so I'd like to guys just post whatever you want and talk to me, and we'll have a nice conversation for the next an hour and a half or something like that. So hello Keith and Yannick and Paulson, welcome. Nice to see you guys. I hope you're doing great. So let's open them up, because why not, right? So I have my props as well prepared. I might move the camera slightly as well. Let's see if I can get it a little bit closer here, so you could. Will that work? If I'm gonna move stuff around, my cable isn't long enough, I guess. Okay, that will work. So, I bought 3. 3 was the maximum you could get in the 360 in the UK. £3 was also the shipping, so one of the reasons I didn't get just one, I got more than one, because otherwise I would pay equal amount of money for shipping, which is, well, retarded. Let's open them up. They arrived very quickly, so it was less than 24 hours actually, and I had them on my porch. And let's open all of them and talk about them in detail. I only know a little bit of information, so I'm by far not an expert on these things, but these are not Raspberry Pis. Like, there's not raspberries that you kind of expect them to do. They have more in common with Arduino Nano devices than they have with Raspberry. And what's the point of it? I guess at first I actually thought that a Raspberry Pi is being cheeky and launching a competition or competitive device against the Arduino, because Arduino was the place to go if you wanted to get really nicely supported microcontrollers for electronic projects, and obviously Raspberry was taking the niche of connected and single board computers niche. Oh, Steve managed to get some. Congratulations. Did you get a maximum number of 3 or just one to play with? Thanks for streaming this, taking time for... No, I'm very happy to share this stuff. So originally, I thought that was the case, but then I came across the Twitter post and read the Raspberry Pi article in detail when they shared that they're actually sharing the silicon with Arduino as well, and Arduino is going to have a very similar board in offer. This is brilliant news, because apart from picking your own ecosystem that you can work with, so you can pick one board having the same processing unit or microcontroller, I'm showing the wrong thing. Apart from having that one board from a single company, you're gonna have the same chip available across different companies, and they're gonna be all pulling in slightly different directions, something tells me. So that's a good thing for us as customers, because you're gonna see all makers of all kinds, whether you're into connected hardware or whether you're more into electronic, contributing towards a common pool of all projects that you can try out and follow and learn something new, and this is always a positive thing. So I'm really glad that then the guys are cooperating. So in terms of sizing, let's take a look. I've got some samples in here. So this is obviously Raspberry Pi Zero, this is Raspberry Pi a 0W, this is the Raspberry Pi Zero, and those are the new boards. As you can see, they're slightly smaller. I'd say like surface-wise, they may be like twice less. They take a space of a... Oh, I can't speak English today. But they're smaller, and that's the footprint. They are slightly bigger than the Arduino Nano. So this is the Nano format. It's not original one, well, something I picked up from AliExpress, but it's a very similar form factor. And this is Arduino. I should talk about this more in details because it's a fun little device. And there is also my favorite ESP8266 to kind of give you a reference of how big they are. So I guess that I'm going to give you an overview of sizing for this. Can I can zoom in. I can zoom in, guys. All I have to do is just lower my... I think that's a little bit better for you so you can see. Okay. So that's the sizing reference, and I've done only a little bit of reading, just kind of to get the generic idea. And I've mentioned that they are more similar to microcontrollers than to Raspberry Pi. Obviously, they are not connected, so they're not connected to internet. There's only a single processing unit that's gonna process the information from GPIO and make the calculation. Without floating point calculations, which is going to make it slightly slower than, for example, like Raspberry Pi for those calculations, but it's still possible to use it for many things. So I think for the majority of us, we're going to be looking into several advantages. First of all, they're going to be very power friendly, so they're not going to consume as much power, so your battery operated projects will be able to run for a very long time. With internal RTC, RTC stands for real-time clock, you can take advantage of that and offload timings to that and lower the power usage and extend sleep modes beyond that. This is also great if you're looking to have an unsupported device for a long time that wakes up on the timer and performs operations and returns back or writes logs, etc., etc. May have some tea. Earl Grey with honey, really lovely. So I've mentioned this is similar to a Nano Arduino Nano devices in the same form, really, because it's gonna be taking place of Arduino Nano in terms of projects. So you're gonna be using these boards. Where would you use Arduino? So to control electronic systems, to translate analog to digital, and to have access to lots of GPIO pins at a lower latency, because that's where it came to. Even with ESP boards, ESP are quite powerful and obviously they feature internet connectivity, but there is increased latency between pins that you have on the device and the processing unit, because there is a little bit more programming going on in order to use that information from pins. For majority of us, it will make very little difference, but if you want to control your application in the most responsive way, going with a microcontroller like this, it's a way to go, and you can expect the latency being much better with new Raspberry Pi boards than ESP. And I think a lot of people were kind of scratching their head thinking, wait, we can use ESP boards, why do we need this? Well, technically we don't, but there is a very strong benefit of having this supported by Raspberry Pi and Arduino. If you follow the single board computers for some time, you came across tons of devices, and not all of these brands stick around, and a couple of they're still releasing boards, but it's all down to community. And what Raspberry and Arduino had proven, that they are able to maintain very rich community and support products for a long time. People are still making projects for Raspberry Pi 2s and Raspberry Pi 1s, and that's, I don't want to lie, but that's about 6, 7, 8 years now. So you will be pressed to actually find another company that would be supporting products and encouraging people to make products using that hardware. And moving forward, I think it makes more sense to have a designated chip that deals with electronics rather than connected things. that you can incorporate easily with Raspberry Pi, because at the end of the day, I think that was the goal of the release, that you could have a microcontroller that you can add to Raspberry Pi and have that seamless connectivity between two devices. And I think with a couple of weeks or months, we're going to see very nicely written libraries to make that very easy to use, and perhaps some hats that incorporate one of these on top of devices like Raspberry Pi Zero or just regular Raspberry Pis. So that's kind of the overview. If you want, we can kind of go through a little bit of stats and kind of... Oh, Electromaker! Hey! Hello, Ian. How are you doing? We can go over a couple of stats on here on the P-Hut to explain what I'm talking about. So I've read that there is actually support to add your memory modules. I'm not 100% sure where, but this information kind of got highlighted by a friend of mine, so I'll be looking into that. But one of the things I've also noticed is that the register is 32 bits, so because the device has 30 pins, you will be able to address all of them at once. I think Arduino, if I remember correctly, you can only write 8 pins at a time. So it's going to be faster if you have more pins used for connectivity. Your timing is going to be much better, and you'll be able to drive them at the same time rather than sequentially, which is going to improve the timings of your items. So in terms of scope or performance of this board, it's going to be slightly better than the Arduino Nano right now, but because Arduino is going to introduce exactly the same microcontroller on their boards, obviously we're going to see a bit of a changes, and the both companies going to be playing nicely to our advantage. Okay, so let's go over to a little bit more of the details in here. So we have a dual ARM Core X M0 processor. They've taken over the silicon production, so it's basically a silicon chip designed by Raspberry Pi. It's huge for them. I'm not 100% sure how else gonna benefit them in other than having actual control over the silicon. So they're gonna be a little bit more in charge of what they're doing with the boards. But it's huge, and I'm glad they actually going that direction, because that will give them a flexibility and maybe a little bit of experience in producing future boards. That's my guess. It's not sure information, but this is my guess in regards to this. So in terms of memory, you have a 2 megs of onboard flash memory. This is where I said you can expand that to 16, and I'm not 100% sure how you can do that right now, whether you can do it through GPA or so. There is a, I don't see, let's have a look together at the board again in a closer setting. So I can't see any pins that you could add this right now, like straight away, but that's what I've heard, and that's what we're gonna be probably reading on at some point. Yeah, but the board, come on, focus. This is the point when the camera decides it's not to focus. Ah, there you have it. So this is the board in a full class. Unfortunately, it's not USB-C, which I'm slightly disappointed. But yeah, this is micro USB. There's a button in here that you can use to load the programs. You have to press the button, put the cable in, and you're gonna have this in flash mode, or you can just transfer stuff into kind of like a USB storage device. And this is the back. It's nice that it's labeled, so all the pins are nicely displayed, so you'll know what you're dealing with. There's plenty of GPIOs to use. It's 3.3 volts, so the advantage of the, obviously, Arduino Nano is work with the 5 volts. There might be advantage or disadvantage, really depending on what you're aiming for. But in terms of battery consumption, you're gonna be really good with these, because you can power these with 1.8 volts to 5.5 volts, if I remember correctly, which means you might not care if you're using a power supply, but if you use the battery, you'll quickly notice that you could have a battery, like a 5-volt battery supply, right? And you could wait until this battery drains down to like 2 volts before you actually run out of juice to power this. So this is an interesting application in terms of having this operated with a battery and with a you should be able to see the gains straight away using boards over the Arduino Nano, which requires the 5-volt batteries, and obviously that's slightly more complicated in terms of supplying voltage. If you just joined, those are the latest Raspberry Pi Picos. This is Raspberry Pi Zero for size, so it's about half the surface. And this is form factor of Arduino Nano, and this is ESP8266, and this is Arduino. So yeah, I'll be more impressed if there was a USB Type-C, but that's my personal pet hate right now, because I keep on looking for different cables, and it's really, really annoying. Okay, so looking back at what else do we have? Obviously we have 26 multi-directional GPIO functions. You have 2 SPs, 2 I2C, 2 UART, 3 12-bit analog to digital, and 16 controllable PWMs. So that board will be able to drive a lot of stepper motors. I can totally see this being utilized in robotics to control this, which is nice. It's a custom silicon from Raspberry Pi, completely new chip. Yep, that's the one. It's called, what is it called? It has a nice name, to 2040 RP, or Raspberry Pi 2040. I'm glad they didn't name it 2020, because that would be really, really disappointing. I think you have, let me check up on the chat. Hello to Milan, and hello to Neo, and Mr. Simula, hello. And they're just gonna actually desolder the flash and add a new one to extend the memory mat. Okay, yeah, so at least that was on point. So you'll have to desolder the flash, and the flash is, which one is it? Is it marked here? Can we have it in the picture, maybe? It's gonna be one of these somewhere. I don't know which one. I'll have to check the references. There's no references here, isn't it? No. Word. So this is a breakdown of the pins right now, you can see on the screen. And what else do we have? We have a temperature sensor, which is new. The temperature sensor, I think that's going to be this silver one, maybe? I've seen temperature sensors like this before, so that might be this one, but I'm guessing at this point right now. So don't trust anything I say right now, because I'm guessing. But it will be interesting to see whether the temperature is actually, well, true, or whether it's affected by the temperature radiating from the board itself. And we have I've mentioned real-time clock, which is going to be perfect for applications that requires prolonged sleep time, because you can offload, my camera just moved, because you can offload the wait times. Instead of running the main processor in low power mode, you offload that instructions to real-time clock. And I believe real-time clock should have also a way to be interrupted, which is brilliant if you're planning on longevity on the battery life. What else? Accelerated floating point libraries. So that's fancy saying point that they don't have a chip that is able to make calculations in float points. So it's going to be slightly slower if you're making complicated operations, but they've put the libraries to aid this. And hello, DIY in the ghetto. And we have 8 programmable I/O PIO state machines for custom peripheral support. I haven't got a clue. This is something I probably have to read on, because I'm not 100% sure how we use that. So if anyone has an idea how to use that, feel free to type it in the chat and let everyone informed, because I don't know. I didn't, like I said, I'm going into this blind. I've read 2 articles, then I fell asleep. I was reading after the dentist, and I fell asleep a little bit for too long. And yeah, come in unprepared. So the plan, what is the plan? I have a strip, I have a strip somewhere in here. So, oh, there it is. There is a nice strip. We could power this on and drive, probably not all of it, but let's pick a couple of them and drive a couple of them and maybe try. I've seen somewhere flash there was a library for W2812s, which, as it happened, they are. So we should be able to maybe run an animation on that if I'm lucky. But I also discovered that attached manuals for setting this up and trying it out was like 270 pages long on PDF. So I got discouraged at this point, saying, you know what, I do need that nap and I need fresh brain to approach this. So the price-wise, I don't know how you feel about 370. I think it's £360 or $4. I think it's a reasonable price. It's not, especially if it's made from UK. Obviously, we have different economy in terms of manufacturing things, so things get to be a little bit more expensive than produced in countries like China. But it supports local economy, and you'll have your device to play with. I think it's not a very expensive board to play with, and it could be a source of your heart of your projects. Right, so moving on, we're just going to go to Raspberry Pi, and obviously we're gonna click on first. Oh, look at this! Look at this! I was just talking about this, and yeah, hey, so. That's going to be probably just describing, what is it? Programmable define. That looks like assembly rather than anything. What is this programming language? So you see, I've mentioned this, that we have programmable IOPO setup, implement the control protocol on state machine rather than main process cores. This is like a PID, no, not PID, what's it called, logical controller units that are used for home automation, like industrial home automations, when you can use them to actually create logic states. I think this is kind of heading this direction from how it sounds. You don't have to dedicate any processor time to sending data out. Secondly, having two cores means that we can use one of the processor cores to deter the pixels, shift them rapidly between brightness. Okay, so for example, if we wanted to brightness level halfway between levels 3 and 4, we would flick the brightness back and forth. We can do that fast enough. Okay, yeah, there. Okay, so that's what it is. You can use them independently from the processor and make them do stuff for you. But as you can see, this is a totally new language for me to I'm not even going to try this right now with this code. I'm just going to, I think I'm gonna refer to the traditional one, because I'll be spending either gonna be just copying and pasting stuff or just reading this instead. But yeah, but this is something I'm definitely gonna add to my reading list soon, because I would like to try it. But we're gonna go to the main thread, and we will get into setting up SDK for it. So we have obviously a choice between MicroPython and C+ or C. I don't have much preference. It's been ages since I did stuff with Python, so I'm afraid I'm going to be embarrassed. So I might opt out for C. It also supports Visual Studio Code, something I've been using recently for work in C# flavor. So that's something to bear in mind in terms of what you can program it with. And obviously it's connected with, you can do it from Raspberry Pi itself directly, which is nice. Okay. So those are device I want to get a setup instructions. I've seen it, so toolchain, hello to a toolchain. And so we have a specification, some design files, step file, first thing parts. So as usual, everything is open source and you can have a look how it's built, use that to create your enclosures and fun stuff. We will go MicroPython or C++. Which one would you like, guys? What do you prefer? Where you can help me more? That's the question. I'm probably gonna go with, maybe let's see which one's quicker. So we have a blinker LED, say hello world, Pico, C, C++ SDK. So you can do command line SDK setup and then full documentation. All right, take care, good Paulson. It was nice to see you. Thanks for visiting. Okay. So technically, what I have to do is just grab a cable, which is micro USB cable. I think I have a cable somewhere here. I know some of the cables I have, they are not data cables, and this always bothers me. Forgive me while I'm digging through the cables to try to find one that definitely have a support. Oh, found it. So let's connect it. And let's get that connected, right? It's a short cable. So what happened now, if I'm gonna press the button on this and plug it in, it will go into a mode which displays the drive, right? So I'm gonna do that. Okay. Hey, there you have it. You can see it on the screen. This is a Raspberry Pi Pico. Right now on your screen there is info UF2TXT. Let's have a look what it does. So it's just the information about the bootloader and model and everything. So that's one of it. And there is a index HTM. Let's have a quick look. And it has just some information here. Okay, fair play. Right, so we can easily discard that. We can download a UF2 blink file. So let's do that. I've downloaded this file. Now we can. Did I close that folder? I have. This one. How much? 127 megabytes of space. Okay. If you say so. Can we have this? Okay, so we're gonna put that in here. Okay. And now, if I'm going to connect it to power, so I'm just going to put it on the desk so you can see it. Now let me switch to a desk. We're gonna have it blinking at us. That's the most advanced programming technique that everyone has to do first, right? So as soon as I'm gonna connect this to this is just the power right now. It's blinking. So it does the same thing that it's supposed to do on a screen. So I've achieved something. And to prove me that I'm not lying, if I'm gonna connect this one's not going to blink because it's not been programmed. So there you have it. We just made the first really advanced program, and we should all be proud. So because I'm gonna be working now, I'm not going to be showing the devices much now until we get LED connected or something. I'm just going to move the camera here, show you my mess behind me, and yeah, we're gonna try to do something a little bit more advanced. Let me go through the chat. So we're going to go with C++, it looks like. Yeah, I think I'm a little bit too embarrassed to try my Python. I've started with Python, but ever since I've been doing stuff in C, so I kind of feel more comfortable with C. Visual Hello World, that's the second one. Okay, so we're gonna have a... this is done with the Raspberry Pi. Okay, okay, well, let's try the second one. Why not? So I'm just going to disconnect my device, and we're gonna go for the second example, just to get ourselves familiar. Like I said, I've not used the platform before. I haven't got a clue what I'm doing right now. And it's always like that. You know, all the makers and everyone, they might pretend they did what they're doing, but the first time they're gonna get a new device, they're like, okay, how do I do this? And 10 minutes later, they're obviously whizzing through everything, and everyone picks up at their own speed. But a lot of people just starting like this, just trying examples and seeing what happens to kind of understand what's required to play with particular device. So let's save this, and let's transfer a second one, which is a Hello World, to this Raspberry. I think it's it's a different one. So I forgot to I think I forgot to hold the button. I don't remember. So I'm just going to do it one more time. Okay, so it's there. So now that I'm connected to computer, because obviously you have to do it with the computer, we have to open the command line. I wonder if PowerShell will work. Do you reckon? Because those are Linux instructions, so I'm not going to be able to do it with a what is it called, with the Windows. I would have to connect it through Linux. I would have to SSH to Raspberry Pi. Should we do it? Yes, let's do this. I'm just going to put it, plug it into my Raspberry Pi and see what happens. Okay, so I've plugged it to my Raspberry Pi right now, and we can connect to my Raspberry Pi. Alright, we had some instructions in there, complicated instructions to follow, which involve 2 lines of code I don't already remember. So let's go to that and let's do this. You can see the screen? I think you can't see the screen. Hold on a sec. Alright, so I've connected to my Raspberry Pi. Let's do this. So we've got sudo apt, not typing, sudo apt install, and then we have minicom. Yes, I won't. And did I say hello to everyone? Hello, Ahmed, and hello. Ooh, that's going to be hard to explain. Yiglitin, I guess. And hello, Mo. How are you doing? I don't know if it's a review. It's me trying to make it work. I wouldn't call it a review right now. We're just messing up. Right, so I've got a minicon installed, which means I can do minicon. And then we're going for baud rate. Baud rate is 115200. Then we have a flag O. I haven't got a clue. Open, maybe. I don't know. And then we have a D for device. And my device is going to be obviously... Ooh, I don't know if... Let's... ls... Because I have a couple of USB ports occupied. So it's going to be one of these. Okay, let's try this again, right? So not to keep you waiting. So let's try. Okay, Control Z to help on a special case. Yeah, that's the wrong device. I think. It didn't say hello world to me, so that's a wrong device. Okay, Control Z. Control icon. That's help. I don't want to. Okay, I just want to exit. Come on. Why? Okay. Z. And we have some options, which I'm clueless about right now. So paste file, right now, terminal settings, and break. Okay, so this is kind of how we run scripts. So those are commands. How to exit? Exit X. Okay, so you just type X, I guess. Yes, okay. Right. So what was my other device that was possibly this was on? Let's have a look. I think that's gonna be here. That's because I've not seen this before. So what we're gonna do? No. MEA1. Oh, the MEA0, sorry, not 1. No. Maybe it was. I'm doing something. Whoa, am I missing something, guys? It should be talking to me, right? It should be telling me hello world, and it doesn't. Let's see, what's the information saying? Okay, yeah, that's it then. So where else I could have it? I think I have just a... No? It doesn't. I've rebooted the... Did I? Let me just make sure I'm gonna reboot. Oh no, I've rebooted because I've connected it to Raspberry Pi, so it shouldn't be a problem. What I'm going to do... typoed up, you put AMA1. Did I? Let's have a look. Did I type it out? AMA 0. I think I've got it. TTY AMA 0. Okay, let's backtrack. See what I did. TT. Still nothing. Okay. Control A Z. It's nothing happening right now. No. It's for some reasons keep hanging on this. But we're narrowing the number of ports, right? So we're gonna. I've tried correctly TTYS0. TTY ACM 0, that was the first. We've tried that, didn't work, right? MAA 0 didn't, and TTYS 0 didn't work as well. Okay. Disconnect and look at the TTYs. Yeah, that's what was my next one. So let's disconnect and let's do this again. It's disconnected. It's proof. It's dangling here, and so so there was nothing out of here. So what we've got, spot the difference, guys. That's what we're playing right now. Spot the difference. 10, 12, 13, 14, 15, 8. Yeah, that look okay. Who else? Who first gonna spot the difference? Go. It must be somewhere here. 62, 7, 8, 9, 7, 8, 9, 61. They look the same. 51, 52, 3, 4, 5, 6, 7, 9, 6, 6, 0, 1. Yes. They look the same to me. Maybe try like this, maybe, okay? But that's gonna give me an ID. It doesn't gonna give me a... Oh, sorry, there's nothing else on the list. Just gonna plug it again and see what's gonna change. And this time I'm going to plug it to USB type USB 2.0. See what has changed, because I was using USB 3.0. Maybe it's not, doesn't like it. Like this. No. No. Okay, we're gonna do it. Yeah, did I? Was it there? Yeah, it was. Okay. Yeah, it looks the same. I broke it, guys. I broke it. Right. So you can do it from the command line for walkthrough of getting through SDK route to getting started documentation. Okay. Right. See, that was the PDF I was referring to. And the problem with this PDF I have, that if you scroll down, okay, this is the short one, this is 70 pages, which isn't that bad. But, God, working in Visual Studio Code. So let's try this. So, hello Visual Studio Code, nice to see you here. Don't save. I'm just going to make it like this, no thanks. And right. So we're gonna try from a command line. Yes, I would like to work with who wouldn't like? Is it available in Arduino IDE by any chance? Want to use video code to debug your local Pi Pico, create a launch JSON file for your project. Example launcher as well, chapter 6 should work. Just need to copy into your project directory as VS Code launch JSON. Okay, so you have to create a directory for your project and then copy the code from chapter 6. Hello, chapter 6. So installing Visual Studio Code. I already have it installed. Now, something tells me this is actually on the Raspberry Pi, because those are installation for Linux. Can I have it on Windows, pretty please? This is where it sucks not to be a Linux guy, right? Let's have a look. Do I have somewhere a guide for Windows? Oh, building MS on Windows. There we go. So, GCC compiler, CMake, build tools for Visual Studio 19. So it's not using Visual Studio Code. Python 3 already installed, and Git I have it installed. So toolchain for this. You see, that's what kind of is going to be slightly annoying, because until the toolchain is kind of done in a single executable like Arduino did, it's going to be really, really. But let me be cheeky, and let's open Arduino. Since Arduino's already is going to support this, sooner or later you're going to see that in the board manager, right? At least that would be my assumption. So let's take a quick look at the board manager and see whether we have BR 2040. We do not. And that's disappointing. I'm not going to see it here yet. Yeah, no. Nope. Nah. I wanted to be cheeky, didn't work. Okay, so they ask for Visual Studio 2019 instead of Visual Studio Code, which is annoying already. Can I have it on Visual Studio Code? Yes, I can. So why it's insisting on? It just needs to put build tools. Okay, build tools for Visual Studio download. Come on. Let's put it in desk downloads. And let's quickly install this. Yes, continue, thank you. It's downloading some more stuff. You can see it here. Show Okay, in the meantime, we can try to do this, maybe. No, nothing. Is it connected? It is still connected. Okay, so we have installation. So that's the build tools. Do I have to anything specific from here? So I can close this one. So just the C++ build tools. So that's what you need to install. 6 gigs. It's a good thing I've upgraded, guys, because you would be here forever, right? Oh god. I bet you will be soon. If Arduino had other fruit making boards, then yes, that's why I'm hoping that Arduino IDE is going to be there. It's going to be quick, because this is not the hooks you only go with a microcontroller like this, because it kills all the joy. By now, I should have everything. I understand that copying a project, compiled project on the Raspberry Pi, this tiny, it's awesome and it's brilliant. But if you have to go through so many hoops in order to get it set up, you're missing the point. People not going to go through all this until there is a simpler way. Maybe we should look in the meantime, right, while this is installing, into a MicroPython, because you can do MicroPython like this. So let's Raspberry Pi. Let's go this one and go to MicroPython, and I'll embarrass myself with my Python skills. So that uses Stony IDE, right? I remember, but can I do it on Windows? Was it this link? Yeah, this one has a MicroPython firmware. Okay, so we can go through this. So breadboard, power on, connect pins. We are good. Install Stony on the Raspberry Pi on operating systems. Hello, browser. Great. Right, so we have an IDE for MicroPython, which is nice. I've not tried that one, but we will download for Windows. Installing blah 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 blah. Where's the download? Installing smart screen filter, installing Python bundle. So that's going to be for Python probably link, but I already have it. Smart filter issues, okay. Missing. Okay, so there is a list of problems already. After installing Open Windows command prompt and following just install. I think I already should be able to do it. So let me just call in let me open a folder of my computer or something, because I already have environmental paths set up and everything. Okay, using pip version, however version is available, upgrading time, but that's not the problem. What was the problem? Impulses, setup tools, and tokenize. I think I have a 3 points. What's my Windows? What's my Python version? Ugh. Is the Python going to be here? No, on a default Python 2.7, and it was, which one was using 3.7? Okay, so I've got the wrong one because I've got it for ESP tool. So the install Python 2.7 Windows, and that's how you do it. Okay. Can go with the latest version, right? Okay, let's have a look at the chat, guys. Show device connected, change image to upload. $80 gigs update required. Yeah, that's usually what happens, right? Let's install the Python tools. It's like default Python 2.7. Yeah, I'll get updated Python, set up environmental path, and be done with it, I guess. By default, it's going to be in a C drive, so that should help. So this is why I was not so comfortable at doing this. I knew there's going to be a lot of silly problems, and you're going to watch me install a bunch of things just to get one LED flash. Oh, so now I should have a Python. No? Where did it install? Oh, come on, where did you install it? No, cancel, I don't want this. In the meantime, you know what? No, we're not going to restart it. That's why it's it's a total annoying thing that gets you in. Like, I can't restart the computer midstream. But let's see if it's actually. No, still, let's do it. Pip3. Oh, they have to provide the path. Hey, it worked. Okay, good thinking, Ian. Yeah, I need to add the path at some point, that's all. So using legacy phone since the backup rule, okay, that's fine. Installing, it's still doing its own thing, right? And description, install it using the application data package, Python software foundation, Python 3.0 local casual, which is not on path. Okay, so that's is it still doing a thing? Okay, so we kind of let's have a look if all right, I did that. Oh, I run, no, did I run the update by like a bit of a, yes, I did run an update, apologies. That's what happens when you want to be quick. PowerShell again. That's why it's supposed to, 3, forgot about 3 even. Okay, our version, okay, that's fine. Requirement already satisfied. I guess we have it installed. Like, I don't see any. Yeah, I guess we have it installed. So to run it now, because I've not used it before, installing smart filter, workaround, missing, installing it on Python separately. So there is an installer as well in here, which I've missed because of smart. I've ignored smart filter. Ugh. Don't you love these things? Okay, where is the installer in here? Hey, there is an installer in here, guys. So you get this, you have to click on this and run them anyway, because that's the smart filter, and you're gonna go through this. Yeah, now it's slightly simpler. I accept the agreement. Obviously, I've read it with you guys. You've seen me read it, right? Okay, grab desktop icon, why not, and install this. All of this just to get something done. Let's go. But then you will see me making all the mistakes, and you don't have to make the mistakes. So that's kind of the plan. At least I hope. All right, so we have it here. Let's me find Tommi. Which language do we want? English. And hello, we have it. So which means I need to go and fetch my Raspberry Pico. Hello, Raspberry Pico. Although, if this is Pico, right, and this is Nano, and Nano is smaller than Pico, that this should not be called Pico. That's my theory. That's the bad naming convention. Oh God! You see, Ian. I'm sure you're gonna be showing off that soon on the Electromaker show, and you're gonna make it look like 3 seconds long, and then like there's no problems at all. Everyone's gonna think that the guy knows what he's doing. Not like Matt, he is clueless. That's what's gonna happen. Okay, so what we were doing, I've lost the track. We were following an example, right? We were doing this, right? Okay, so we have this, and we can obviously do the print to make sure it's working. So let's do a initial. Do we do like, I'm confused now. So hello, not enough tech friends. Look at me. I did a bit of a Python. Okay, I forgot, like, you don't do this in Python. I was just like ready for this. Okay, and then we run, will it save automatically? Right, on the Pico following manual, and oh, you'll be asked to save the file. Okay, so that's fine. So if I'm gonna run this now, we're gonna get this file. I'm gonna just do like hello, low, even double O, and we're gonna just place it on the desktop so you could find it easily. Yeah, it works. Now we're gonna be adding to a firmware. So you do that in this can I have it like this? Can I, no. The cable is too short. Like the cable is too short. I can't drag it anymore. So basically, you have to disconnect the Raspberry Pi, press the button, hold the button, plug it in, get it to show like this, and then have our file located. That was hello py, right? Put it on here. Do I have to download IDE on the... I think I have to... Did I miss the step? Then it's a firmware every time you use Raspberry. Next time you just use the shell. Okay, let's see. Connected to a computer, you have a selected MicroPython in the interpreter. It's here. Do I have to select? Or is it already selected? Look at the shell panel at the buttons and yeah, okay. It was saying this. Communicate with Raspberry Pi. I guess. So right now we're running it locally on my Python, which we don't want. We want this to be run on Raspberry Pi. So let's go here and alternative Python 3, remote Python 3. Oh, MicroPython, Raspberry Pi. Okay, so we found it. So if you want to run it on the Raspberry Pi, you have it in a list in here, which is nice. There's also options to run it on ASP, which is also nice. So I'm gonna select this port, try to detect it automatically. Okay. Oh, there was an install update. Sorry, I did a bad thing. Okay, so it's installed automatically. So it gave me this message. Hey, we're doing this, guys. We're doing this. So it sends the MicroPython to Raspberry Pi Pico. And it's done. Okay, close. So now you can see that we are running our code on Raspberry Pi Pico with our Raspberry Pi 2040. So we've done this, yes, after, what is it, where's my timestamp in here? 58 minutes only to get to this point where I can blink or say hello. So now when I run it, this is hello NotEnoughTECH friends being posted to you with Raspberry Pi Pico. Success. Okay. So, but we could blink a LED, right? So we can use it's just a standard call like this, and this is gonna be internal blink, right? So if I'm gonna go to this, and we're going to delete this and just be crude and copy a LED value. So LED value is pin 21. LED value 1 is on, obviously, and then LED value off is 0. And maybe a delay of, was it Python delay? I don't know, 2 seconds, if I remember correctly. So now if we're gonna run it, it'll start blinking at me. It's not delay. What was it sleep? It's been ages since I used Python. I think it was sleep. It wasn't a sleep. What was it? Oh god, I'm really, really bad at this. This is gonna be here, right? Ah, they have a leg toggle as well. They're doing it this way. Okay. So they give a timer function, blink. Because so they use the toggle function, which is already there, and frequencies in seconds. Okay, all right. Now, do I have to save it and run it every time? I think I have to save it and run it every time. Let's have a look. Let's have a quick look. Now, if I'm gonna run the script, no, it's automatically posted. Can I do it? Like, if I disconnect here and then get you to my desk, now I've uploaded this sketch to this board, right? So if I'm gonna get my cable, because I was worried that I have to upload this every single time, but I don't. So if I'm gonna plug it, that's gonna be blinking every 2 seconds, that LED here. No, I have to save it. So that's run on that runs it on the fly. But if you want to save it and transfer it, you'll have to unfortunately do it this way. So it's gonna go back. You have to get your code. You have to I've disconnected, so I need to stop the execution of it. Connect it again because I've disconnected it, so you will discover. Okay, it's connected again, and now I should be able to save it somewhere, right? I can run it, and it's blinking. I can show you that it's blinking. But in order to have it run on my Pico device, I have to send it there. So I actually have to just stop it, maybe. Why? Can I not save it? Why can't I save it right now? I don't understand why I can't save it. But why can't I save it? It makes no sense. Anyone? Does it automatically? Okay, let's have a look. Because I have it already on my desktop. Let's open this notepad. So it automatically saves it. So that's why I didn't have a prompt, because it's automatically saved that on my desktop. Now, if I want to update the sketch that I had in here, I have to press the button again, connect a Raspberry, and now push that updated file to Raspberry Pi. Okay, now it makes sense. Now I understand what I'm doing, more or less. And now when I'm gonna send this hello PY, not going to say hello world, but when I'm going to connect it to a power supply without the computer here, now it should blink every 2 seconds. So that's how it works. You run the code on the fly, but it doesn't save it to a storage yet. You have to actually still transfer it. And my theory, it's not working. So what did I do wrong? Do I have to run it? Do I have to? No, I didn't run the hello world, right? Okay. My theory isn't still correct, so we still have to play a little bit. We're gonna get this figured out. You can laugh at me, I don't mind. But the discovery is an interesting process. So let's restart this. I'm connected back to Raspberry Pi Pico. And when I run this, it's all good, right? It's blinking, it does its own thing, and everything's fine. And this file got updated because I verified it. I went to my desktop, I got to the file wherever it is. This one, right? If I open it with Notepad, it's changed to what it's supposed to be. But when I drag it over, it doesn't work like this. So do I need to compile it or something? Oh, you don't Okay, let's read on. Let's see what they said. Okay, let's go a step back. So then, however, it's better to put longer programs in a file. Yeah, Johnny can save and run multiple programs directly on the Raspberry Pi Pico. In this step, you'll create a MicroPython program to blink on board the on envelope. That's fine. That's what we did. Now, run. I didn't have this. First of all, I didn't have this mod. So enter blink as a file pair, and you need to enter the PI extension. So yeah, we had a hello py, that wasn't a problem. So Tommi can save your program to your Raspberry Pi Pico and run it. So let's see this option, because that's why I would assume that I can actually go and save it and run it. Run current script, select the interpreter. Yeah, do we have any options to save this? Run editor general shell. No. So I didn't get an option to do this. Tools, open shell, 24, open on plugins, options, close, save, move, rename, save as. Okay, like this maybe. Name, hi, py. Okay, now I saved it. Now what I'm going to do, I'm going to go to my desk again, connect it to a power, and see if this loads. And something tells me that I actually don't know. Okay, so it's there, but it does. I think it just doesn't execute right now. So let's go to the next step. I think I'm getting ahead of myself right now. So, okay, save the program, and so I'll be running it back. So this is on the device right now. So let's verify that the program is still there. And I can't see it here. Is it like invisible or something? No. Click run program will click. Yeah, but why cannot, like, I've saved it. I should be able to do it. I'm not 100% sure what's going on. So let's restart the connection. Okay, there is an update suddenly. Let's do the update. Maybe there is a problem. Close. And let's have a look at what chat is. I just did. Sorry, I didn't change the camera. I just did the update on the for the MicroPython on the Raspberry Pi Pico for some reason. So I don't know. Maybe that will work. So let's have a look. Select time and wait. What? Where to save? Upload the TTF file. Sorry, generally. It was like I've tried a UFT file, and now we're following MicroPython. It's supposed to be working, which it isn't. You can choose the port. Yes, I can choose the port, but it's auto-select, so I don't have to. Delete the file on the Pico and re-upload it. There was not any file on the Pico, so if you take a look in here, right, we can still connect it to it. Let's connect it to it. So there is no file in here, right? I think I can get that deleted anyway, right? So I have this, right? Now, this is my new script. I've put the script in here. I've closed it. It's saved, right? You haven't even run, but because I know, but I'm trying to make it executable, and now would assume that it would pick the only file, or do I have to? It doesn't actually specify what do I have to do to make it run on its own, because. Because I can't select anything, there is no like it says like, oh, you know what you have to do? Just name the program startup and it will start automatically. So if I'm just going to now connect the board again, see the file's gone, it's saved probably to flash. And in a normal mode, what's happened? Do I have anything in a normal mode? No, it's not visible in the normal mode. Okay. So yeah, but I can still, like, I can reconnect it and I can still run it, but I'm running, pretty sure I'm running this one. It's, yeah, it's blinking, but I'm not 100% sure what's going on. Okay, so let's, it says about UF2 and fine onto Pico. Okay, let's go to the next step. Let's see what's gonna happen with this project, because they're obviously running it from without console, maybe. Okay, let's take a look what happens. Run your program, then when you press the button, you should toggle. So in this case, we're still connected to a Sony. We're running the program, and then we're using the button on the breadboard to blink the LED. But how to trigger this from actual device when it's just connected? I don't. Because in Arduino, all you have a main loop that constantly runs, and yeah, and that works. But I didn't, I didn't grasp how they resolve this in here. It's like, I understand I can just run the file from, you know, from the Tommi IDE, but well, that's not the point. At some point, I want to disconnect it, put it elsewhere, and make it self-run the project. And I kind of missed. Did I miss the instructions about it? Was I too quick? Okay. Okay. I think we, if you want, well, here you go, guys. So in Tommi, click File, Save As, and you have to name it as a main PY. That's why I was talking. There was no instruction to until now. Why this is not a first thing? This should be a first thing, saying like, if you want to run it from a IDE, use Run button. If you want to run it from the device itself, rename the file to main PY. And that's what it was. So now if I'm going to go File, Save As, Pico, and so you see I have a high, so I'm going to save as main PY. I was tempted to try this actually. Now I'm going to disconnect it. We're going to go to my desk. I'm taking the cable, going to connect it to power. Right, I've got power here. And now when I connect it, I fully expect this LED to blink every 2.5 seconds. Ta-da! Yes! I've made it blink again. Oh god, I don't know where guys you have patience for me. Well, we made one LED blink. That's a success. I call it a success. God, it only takes us 1 hour and 13 minutes. Oh, God forbid. But yeah, I'm gonna be fighting the C++ tutorial because it's like this. But at least once you kind of like, if you want to just try it first, just go for MicroPython. Like, don't even think. Go for MicroPython. And you know what's kind of interesting? Like, I'm really tempted to be a little bit cheeky. I know the libraries won't work, but if you're gonna go, right? You remember me? Do you remember this? We can do this one. That's fine. Do you remember the M5 stacks stuff? Now, because that uses MicroPython as well, right? I know the library supporting library is going to be wrong, but this is the thing that is that's cool. I can just put my API key, right? And right now I'm not going to do it, but I can put my API key and start playing with like random stuff to generate either random stuff. Doesn't matter. And then just get information in MicroPython, because that uses a MicroPython as well. So it's a way around. If you just knew you want to experiment, you can still use basic MicroPython commands, obviously everything that requires hardware support is going to have to be defined in the script itself. So you'll have to go to Tommi and define your pins and everything. But you can actually create a lot of code from here instead. So if you want to, like this one, can I just close it? Delete. So if you want to create a variable, okay, and set a variable to this and delete this, and to, where was the text? There was a text here. To text, right? Hi, and then let's rename variable to something, var1. So now that's, you see, that's gonna be complete. That's gonna be a legit, apart from this one, because obviously we didn't set the color. But that's gonna be a legit, Python in here, which you can later use in Tommi if you're just not feeling up for just jumping straight into code. So that's a small kind of cheat that you can use. But like I said, any hardware interaction you'll have to just discard. So obviously from here you're not going to be importing anything from these libraries. You're going to be using just a plain old MicroPython. But that's a workaround that you can use until better tools are available for this. So if you want to give it a go, then this is something I would also recommend. So let's okay, let's click on through, and what next? For the documentation, that's going to take us to this page. Okay, MicroPython, where we have drag and drop. So that's where we have drag and drop, white Python efficient guide. You see, and this is the thing, is like, oh, I wish they kind of add a little bit better. That should be telling you straight away how to do the thing that took me 1 hour to kind of figure out. And it really shouldn't. It should be really concise in a like first video tells you do this, install this exactly file. If you don't have a supporting libraries, do this, and then I wish that was slightly better explained how to do it. But maybe it's me. But if anyone new wants to jump on the Raspberry Pi Micro, then I think they're gonna face kind of the same questions at first. If they've not done anything like it, I have suspicion that they're gonna have not the most pleasant time. How to get started? Yeah, I think that's how that's what I'm gonna do next. I got a very short video how to get started quickly without all that 1 hour of me trying to look around and scratching my head what to do next, because it's a bit daft that yeah, uploading the code is simple. You can drag and drop it, but no one wants to. Everyone wants to, grab LEDs and connect it. So speaking of LEDs, I've seen in a reference somewhere that there was a library, but that was for C++, right? There was a library. Leave this for C++ somewhere here. This one. Okay, so this is the library for WS2812, which you can use, and this is for C++. No, this is for this is for Python, guys. Should we go for it? Of course we should. Let me zoom out a little bit and let me go to my desk. You see, I have a nice breadboard embedded in my desk. I've got some LEDs. I'm probably gonna need some power supply. I've got power supply in here as well to feed it. So, and those are definitely the LEDs I need. Oh, hold on. This is power. Oh, this is RGB. Why do I have these two extra? No, don't have to be WS. Yeah, they do. I think it's just to supply extra voltage or something, that's all it is. So green's gonna be, let me get my multimeter quickly, and I confirm, I think green's gonna be my signal. So let's have a quick check. So the way you can check it is if Obviously in here you have ground, signal and voltage. So if I'm gonna go with signal, touchscreen, new. Can I would have to ideally do it on this side, but I don't know if that's after it. Yes, should be able to do it. Check ground. Yeah, this is green, is the signal. So I should be able to use DuPont cables. So let me grab a couple of cables. Male to male cables. There you have it. So we're gonna need something. We're gonna use green for LEDs, right? There you have it. Can I just like pin it into like that? We're gonna pick in the pin in a second. We're gonna need some power, so I need to strip those, and they're gonna be power strip. Where's my wire stripper? Here it is. So let's strip those really quick. Oh, why my wire stripper is not working? Is there any dirt in there? Oh, come on. Okay, that worked. Why not? My wire stripper is slipping. Ah, this one's a little bit loose. Okay. Fair enough, mystery solved. Yeah, there you have it. Okay, we have a power supply. We're gonna power everything together. So we're gonna need one for ground, so we're gonna have to locate the ground. Ground is here. One for signal, which is gonna be our green, and some power supply. They obviously have resistors in, so you shouldn't have any problems. Black, it's obviously white, and red is gonna be obviously red. So you have our supply sorted. Now we need to come on the ground, so we're gonna get another cable. Yellow's fine, and we're gonna connect it to this pin. Can I just kind of like, let's wrap it around before I clamp on it. That's the best way to do it. Probably not the best way, but it's the quickest way to do it. I already wasted like 1 hour trying to figure out, and was hoping by that time I would have everything sorted. Okay, now we're gonna set a power supply to a, can I show you? Can I maybe? Like this? I can use this one. No, this one's too far, okay. So let's set the power supply. Those are, I don't remember how many volts they need. I think 5 volts. So we have 5 volts, half an amp for now. Maybe crank up amperage a little bit to 1 amp. That should be enough. Okay, so that's going to be my voltage, and it's upside down, sorry. So that's going to be sorted. Now let's take a look at our tutorial and see which pins they're using for quick check, right? So you have some examples. We have fireflies. Well, let's do fireflies, and let's copy it all, and then go to Tommi. Gonna be saving everything. Oh, that's a bad copy. All I needed is this. Right. Thank you, whoever wrote this. Benevi. Okay. Now we're gonna save us. It's not connected to, we need to connect to my Raspberry Pi. Let's connect to Raspberry Pi. Okay. File, save as. No. going to get it in a boot mode. Maybe. Wow. Save as. Oh, do I probably need? Okay. I need to restart. So each time, ask me for this. And close. Okay. So it's connected now. Now I can do save as, right? Save as. Yes. Raspberry Pi, and we're gonna be saving as a main PY. So we have this. Yes. We want to save the existing editors first. So I can do just this. And what we have brightness 20, number of pixels 50, that's fine. And where are they connected? Did I miss the pin definition somewhere? So, number of pixels pin where the no pixels are connected. Zero. Why? So which one is the? Come on, guys. Which one is the pin right now? It's the second of the. It's colors. That's fine. Min length, month length flashing, number of flashes, pix color flashing. I can't. How it's defined? Where's the pin definition? Okay, let's check the. Import this in GPL number in order. So state machine like with the parameters of number at least, state machine ID and GPIO number in order. So it creates strip of tablets and machine 0 and GPIO 0. You use okay. So GPIO state machine 0 and GPIO 0, it means that the first one is 10 LEDs, state machine, and then that would be GPIO. So the last one is GPIO then. That's at least how I interpret things. So let's take a look. In here we have number of pixels, which is 50. I don't know how many I've got. That's probably about right down. First 50 we're going to be concerned with. State machine we're going to leave 0, and GPIO, like where's my GPIO? Let's have a look. Which one is easy to use? Yeah, we can do GPIO 0. It is the first one on the top. Okay. Fair enough. So we're gonna leave it at that. So I'm just disconnecting this. It's saved as a main PY. We're gonna go to our desk and let's make a circuit. So GPIO 0, it's this one on the top in here. So that's what we're gonna connect it to. Right now I'm not running any power, so I can still just mess about. So we're connecting GPIO 0 like this, and we need to make a common ground connection to make sure that the signal is working. So let's figure out also which one is ground. Ground is 1 to third one on the other side. So third one on the other side is ground. 1, 2, 3. So you're gonna pin it, and GPIO let's do it like this. So 1, 2, 3 here, and GPIO is 1 is here, and that's hopefully gonna make enough contact to work. So now when I run this and connect this to power supply, it should work. Do I have a cable long enough? Kind of. Okay. So first we're gonna power the Raspberry Pi, and to be honest I'm gonna just double check because I don't want to blow it up. Yes, the third connection is the power. It's fine. 1, 2, 3. That's the ground. And GPIO 0 is the first pin in here. Then we're going to connect the power. So now it's going to be starting sending signal to GPIOs, but it's not going to do anything until I connect LEDs. Now LEDs are set to 5 volts. If I remember correctly, that should be alright. And let's. Okay, so there is some. I don't see any power on that. There's some voltage being used by this. But not much, okay. It's alright, we're gonna quickly investigate something. Yeah, those are extra voltage strips. Yeah, that should be alright. We had a 0 GPIO. Do we have to? It was definitely making connection. I'm just going to hold it like this and try again. No, I can see a draw of 200 milliamps right now, but nothing's happening. I would assume this is running, right? I've saved that as a main PY. Okay. Well, let's track back. And okay, we have a problem in the line 2. Why there's a problem in line 2? Let's figure out. So as you can see, there is a problem in line 2, no module. Okay, so I didn't download the libraries because I'm stupid. Obviously that wouldn't work. Come on, I need to download this and put it on the drive. So again, let's download the file. Where is it? Where is it? Save link as. Okay. Now we're gonna put this into this mode, transfer the file over. Yeah, you just saying that here to make me happy. I appreciate it, but I'm a retard. And then the main PY, I guess I can transfer it this way now, right? Can I? Do you think so, guys? Let's go. This is update. No, it's main PY. I just have to save it. So stop this. Yes, cancel. File, save as main PY. Okay, and go to my folder, main PY. So I have those two. It doesn't import time and import random. I guess those are part of MicroPython, right? So I should be safe. We'll see what it will say on the reconnect. So I'm just going to reconnect. Run it. No module name. So okay, so let's try to open here. Open from this computer. We're gonna open this. Yeah, okay. So we have a 12, this one. That's fine. And now we are going to save this. Save as. Okay. Yes. And we're going to save this one. And that was VS2812B Pi Y. Okay. Oh. I feel. Jesus Christ, nearly midnight, guys. I just want to see a couple of LEDs shine, that's all. Okay, so we're good, right? If we're gonna run this, we have a line 7 in No, because I need to run this one, sorry. Oh god, okay. Yeah, thanks guys, I see the problem now. I thought it's gonna just save the PY file, why it didn't. Okay, let's do it in a traditional way, right? Just hi. Done. And then go to here, A, B, and then save. And now, when we run it, hey, it's running! It's running, guys! I don't have any problems. It's running. Right, okay, so let's go to my desk. Hello, we meet again. Let's identify if so ground is on this side. And that was a ground yellow, right? That was the third one. Pin it down. And pin it down so I could actually use the other pins as well. And that was 0. Now we're gonna get the power. All this, guys, all this. Okay, so the code's gonna be running as soon as I'm gonna plug this in, but LED's not going to be running because they're not getting any power. And now you can see LEDs, right? So now I'm gonna turn on the power. Oh! Hey! Look at this beautiful LEDs. Oh! So sparkly. And I promise I'm not cheating with this, because I could also do that. Just to pretend. I could also do this. Can I? Oops. Come on. Huh? It's not working, but it's not working. European connectors. There are LEDs in here. You could see them flash. Yeah, but it's running. Yes, we achieved something. So what I'm going to do tomorrow, I'm going to write like, I don't know, 500 words tutorial that basically condense all that 1.5 hour into like 10 minutes, so you could just do this and have, I don't know, LEDs playing for you. And I feel like achieve something, even if that achievement was just to copy a code from one side to another. And yeah, Raspberry Pi Pico for you guys. That was okay. That's once you know how to do it, that was simple. Obviously, just, you know, go and do this. And I just feel like that should be slightly better explained, because if I struggled, people who getting started with it, they're gonna have, I think, a little bit more problems, and it should never be that difficult. And I can't wait for Arduino IDE to have it, because that's gonna be even more simple to manage. And I think the next things that Raspberry Pi guys have to work on is a nice IDE that they can implement into either Raspberry Pi and the computer as well. Ugh. I still feel like a silly person for having this long to get this figured out. But it works. It does a thing and it works, and I kind of achieved the goal, so yeah, yay! Small victories, guys, small victories. Right, it's nearly midnight, so I'm just going to go and do some reading and go to bed. I wake up in the morning, get the post on, and I promise to post it tomorrow. So you guys are gonna be, you're not even interested anymore, because you're gonna be watching this. You're gonna be experts on making single mistake, including downloading libraries with extra HTML code in it and not paying attention, and other silly mistakes that I've done. So you can actually enjoy yourself. I like the live, thanks Ian. I like to do it on a live stream for that very reason, because it's easy to assume that everyone else is smarter than you and they know everything, and it's not. all start in the same way. We plug stuff in. I bought 3 specifically because I was afraid I'm gonna blow up the first one and that would be an embarrassment. So that's the reason I got 3. I don't need 3, but I know myself. I'm gonna do something silly and things gonna explode, and hopefully not. I'm the guy that shocked himself with the main electricity during live stream, god damn it. So yeah, and never get discouraged. So if you struggle with something, everyone does. It's normal to make stupid mistakes. It's normal to get confused even if you get a clear instructions on the screen, because you're rushing in, you think you're supposed to read something, and I've done, I think, an array of mistakes that probably I would have avoided if I spent a little bit more time reading it carefully, but obviously a bit of a live stream pressure and me trying to, you know, whiz through it like I know what I'm doing got me into a couple of dead ends. But yeah, but that's all it's all about, and then the end of it is just a satisfaction, a small satisfaction, even though I've not wrote this code and it's not mine and it's just blinking the way someone else's design. I'm still super happy because it works. I managed to, you know, copy and paste it into the right place, so it works. And the next step is I'm gonna be looking through the code and thinking like, okay, maybe I can change this, maybe I can add a temperature, maybe I add something else. So yeah, that's all it's all about. There was a temperature one, which I'm really quickly want to check. So let's say go to temperature one, because it kind of, so you know, we don't have to do anything else, I think. So let's do this and see what it does, because I'm curious, right? And now I know how to do it. So we can go to main, replace this with temperature. Let's power off the LEDs. We're just gonna run this, and then I'm gonna say my goodbyes to you guys, because otherwise I'm gonna get divorced. So let's connect the Raspberry Pi again, and plug the USB the correct way. Let's go to my screen. So I've already copied the temperature. I want to know what it does, so let's have a look. So it uses ADC converter. There's a conversion factor. So it uses the onboard temperature to set I think the temperature. So let's have a look and see what it does. So temperature 27 minus some reading. Still 0, and sets pixels depending on the temperature. Okay. So basically it shows a number of LEDs based on a temperature reading, I think. Okay, so let's transfer the script. So I'm just gonna have to save. It still uses this one, so it's easy. File, save as. Sorry, we have to restart that. This is gonna be annoying. You have to stop it, and then you can save it. All right, so that's been saved. I can disconnect it. And let's connect it back to and see that lovely temperature. Where's my desk? So I'll do the same thing, connect the Raspberry Pi Pico into the power, and then connect the ground to 1, 2, 3. Double check. Yes, 1, 2, 3. I hate when they put ground next to the 3.3 volts, because you know what's gonna happen. You're gonna swipe the ground against the 3.3 volts and stuff gonna explode. Okay, and now let's put the power on. And nothing happens. Okay, that's all right. That's okay. I think I know what's going on. I think I need to save both files at the same time, maybe. I'm going to check if that compiles, because I didn't check if it compiles, I guess. So I want to make sure there is no mistakes, right? So at least now I know how to troubleshoot it. So hit stop, then let's compile this. It's running, but I just want to make sure that we're gonna save it to Raspberry Pi. Stop. File, save as Raspberry Pi Pico main. Yes. So that's saved, and that's saved. So why this is not running right now? Oh, I've copied it correctly. There is no thing. It compiles, and you can't see my screen. So this compiles nice, so it works. It uses BSW import BES, that's correct. Time and machine. There was no machine. No, there was just the Pico JPEG and this one. So I've downloaded this. So it should be working okay. So why I have a problem with this? File. I'm still busy, can perform current. So okay, so it has the files on here. So I don't know why it didn't. Let's try again, see what's going on. You saved it, but didn't move it to the Pico. That moves it to Pico when you do that. When you click on save. So I've updated the file there. So that shouldn't be a problem really. I'm gonna look up the code. I have to connect something else. Pixels at 0. That's fine. That's being defined. I don't think I have to do anything else. No. So let's see what I've done. I'm gonna connect this. So this is signal. It goes to 0, which is first on this side. Oh, it flashed in here. Maybe the temperature wasn't high enough. Okay, I have a single dot in here right now, which is accidental, to be honest, because it should not be flashing because it doesn't have a power right now. So as soon as I added power, no. Oh, I have a 1 dot, and I don't know if I should have a more. So it kind of oscillates in here. I think this is. Okay, I'm just going to turn off the power. I'll take a look at the code again. Questions? Does it run OS? No, it doesn't. You have to. This is a microcontroller, so it works like Arduino devices, Arduino Nano. You put the code on it and you run it. So let's take a look at the code closer. So what it does? So you define 30 LEDs, right, and you connect them to 0. Then you have your sensor temperature, which is set at ADC, and that's on pin 4. And then you have a conversion factor is 3.3 volts that we have on the individual pins, divided by 65538, and this is 32 bits. Is it? Am I correct? All right, Ian. Thanks so much for watching and helping out. See you on Wednesday, I guess. And then we have a minimum temperature 0, maximum temperature 30. And it maps this using conversion factor, right? So reading is sensor temperature times conversion factor. Temperature equals to 27 minus reading and some maths in here. So that creates an offset. And then temp integer, it's temperature. So we're gonna end up with a value like 6, right, or something. So temp integer. So basically what it does, we should have as many LEDs light up as we have degrees. So it should, it should be doing that and showing the pixels updates every 2 seconds, showing if you have 19 degrees, you have 19 LEDs, and I have, well, 18 degrees, so I should be seeing 18, but for some reason it's not working. But anyway, I think I ran over the allocated time and I'm kind of running over 2 hours now. So yeah, if you've missed it, the meaty stuff happens at 1 hour 10, when I kind of figure out quickly how to get these connected with MicroPython and how to set it up. Kind of like from 1 hour onwards. First, I would recommend first 20 minutes and 1 hour onwards, just kind of skip to avoid all my mistakes. and you'll know how to use the MicroPython, how to connect them, how to flash your first program, and how to use Tommi IDE for MicroPython to make something out of it. So yeah, and just in case you wanted to, you joined and you didn't know, like, this is how they stack against the Raspberry Pi Zero in size, and this is how they stack against the Nano. So they're slightly bigger than Nano, even though they are called Pico. They should be bigger, so they should be micro, really not Pico. And this is how they look like in terms of being as big as ESP 8266. Right. My wife is very forgiving, hopefully. I'll go and check. Right, it's been super cool to have you around, guys, and pointing out all the things I could try. It's always good to have a sanity check and read a couple of really useful advices in that to check stuff out. Tomorrow I'm gonna write a quick tutorial on this, so hopefully no one have to go through that amount of time to get it set up. I know that lots of you are much smarter than me in doing these things, and you'll never end up in the same situation like me, and you're gonna go through it within a second and enjoy your devices if you're gonna end up with. Yeah, if you want, get one of these. They're not very expensive. They're unfortunately out of stock, which I predicted, but yeah, they're fun to play with. They're nothing particularly different from Arduino for the most of the projects. But I think with time you're gonna see a lot of support for these and a lot of cool projects that you're gonna be able to use it as a plug and play. And since Raspberry Pi RP 2040 IC, the heart of this operating of this microcontroller, is gonna be available also on an Arduino board. Soon enough, you're gonna see this in Arduino IDE, and you'll get to enjoy really easy programming that way. So that's pretty much what I've got to say so far. So I'm looking forward to that. So it would be all easy, super, and we're gonna start building projects that truly take advantage of the real-time clock, battery life. And I have a couple of small batteries I can show you. See, I've got those tiny little batteries, which are perfect because they only almost the same size. Ta-da! So the 3.3 volt battery is perfect for this, and I would be able to power this off and to run it for long hours or even days or months, depending on sleep policies, thanks to RTC clock. So thanks so much for everyone, guys. Thanks so much for John and Robert for joining us, and Sahil and Steve, and who else joined us recently, and Dot and Ian from Electromaker, and more along. It's nice to see familiar faces on the live stream, and I always appreciate your encouragement, guys. Right, soon it's going to be a couple of fun articles. I'm still going to work on my heating system this weekend. So PRR sensors, they're going to go live this weekend. I hope so. And yeah, thanks so much for watching. And if you want, there's a couple of links with affiliate purchases. If you're interested in shopping at any of the shops, if you use them, I get extra 2 to 5%, depending how tempting is your shopping list. Right, enjoy your evening, stay safe, and I'll see you very, very soon, I promise. Take care. Bye.